Hey guys, you actually know everything you need to know about trigonometry, the basics, 3 trig functions now. So now we're going to use them to do what's called solving a right triangle, which means you can find all 6 parts. So as an example, let's just draw a quick one so that you know what we're talking about here. This is triangle sun with right angle at U, and that means given very little information, we ought to be able to use trig to find all 6 parts, all 3 of these sides, and all of 3 of these angles. Angle S, angle U, which we know already, 90 degrees, and angle M. Now obviously I don't have any information on this one, so you'll see how little bit of information we can have to solve the entire triangle, finding everything. Yes, surely you know that by now, and hopefully you're getting really good at pointing it out too. Okay, here we go. Example 1. The directions will simply say something like solve each triangle. They may ask for things specifically, but if they say solve each triangle, that means find everything. Round all of our answers to the nearest tenth. So all we have is one side and one angle. So the first thing I'm going to do is label the other sides as something like X and Y, just because when we go to find those, we'll use those proportions like you do anytime to find a missing side, and that'll come in handy. Let's talk about finding angle A right away, because if we have 90 degrees at angle C and 56 at angle B, we know that A and B together have to equal 90, so that could go pretty quick. 90 minus 56 will leave us with angle A. So that should be 34 degrees. I can't write that tiny, so I'm going to squeeze it in right there. Now that you have both acute angles, you can use either angle you want to, and you just pick a trig function that will use that one side value that you have, that is that 8, which in this case happens to be the hypotenuse. So pick either 56 degrees or 34 degrees and go with any trig function that uses the 8, which uses the hypotenuse. I'm going to go with just the sine of angle B, which would be O over H when sitting at angle B. So the sine of 56 degrees should equal opposite, I'm calling that X, that's what I have it labeled as, over the hypotenuse, 8. Set it up as a proportion like you've learned when you're missing a side, and you'll have 1x equals 8 times the sine of 56, and that should turn out to be 6.6. So we just found length AC, because that's what X stood for. Now let's go from there. My picture's so small I'm not going to try to write that on there, but we have 8, we have 6.6, we need a third side, and we'll have everything we need. So now I'm just going, you have some options. You could do the Pythagorean theorem because you have 2 of the 3 sides and it's a right triangle. So you could do that to find what we've labeled as y. Or you can just pick any other trig function which involves that y piece. So I'm going to just choose, literally you can choose any other trig function at this point. So I'm going to choose the cosine of 56 degrees. So once again, sitting at angle B, that would be adjacent over hypotenuse, so that would be y over 8. If I do that as a quick proportion and multiply 1y and cosine of 56 times 8, when I do cosine of 56 degrees times 8, I get 4.5 units, and I just found BC. We have AB is 8, BC is 4.5 units, AC is 6.6 units, angle A is 34 degrees, angle B is 56 degrees, and of course angle C is 90. We have all 6 pieces. All right, in example 1 we had to find everything, but in example 2, once we draw our picture, we only have to answer this specific question. What is the sine of angle R? So let's draw a triangle TRY, and it says y is the right angle. Yours may not look exactly like mine, but the main deal is that y is at the right angle. So I'm going to put T here and R there. That does not matter which one's where. What matters is what we do with this information. Wherever you put T, you now need to label the tangent of T 8 over 15. Tangent is O over A, so if I'm sitting at T, opposite needs to be 8. Adjacent needs to be 15. Now that does not match the picture I drew because my 15 looks shorter than my 8, but that doesn't matter as long as you make the information match. Now the question is, what's the sine of angle R? So let's go circle angle R, and I'm even going to put a little theta symbol there. Well, if I'm sitting at R and want to know the sine of R, I need to know O over H. Opposite of R is a 15 for sure, but I don't know H. So since I don't know H, my only option is to do the Pythagorean theorem because I have two side lengths. So just go to the side and go 15 squared plus 8 squared. That would equal, I'll even call it H squared. Quickly do your math. 225 plus 64 equals H squared. H squared equals 289. If you've memorized some square roots, you know this one without a calculator. H turns out to be 17 units long. So now for the sine of R, now come back over here to this problem. O over H is 15 over 17. We just found the sine of R, and it does say to express your answer as both the fraction, the ratio, and a decimal. So punch in 15 divided by 17, and you'll have the sine of R as a decimal. Okay, everything now that you really need, so let's try to run through example 3 quickly. Once again, draw your triangle to match the information. Y is the right angle. So I'm going to put T and R in the other two spots. And this time we start with this information. The sine of angle R is 3 over 5. So sitting at R, opposite and hypotenuse can tell us where to put the 3 and 5. The question is to find the cosine and the tangent of angle T. So if I'm sitting up here at T, cosine of T is A over H. Tangent of T is O over A. If you have everything, you can just name it and you're done, but I don't think we do. Cosine of T would be 3 over 5, so we do have that. We're done with that one. As a decimal, that's 0.6, so we're done with that one. But to find the tangent of T, we do not have the opposite, but we have the adjacent is 3. So we need and put it over a 3 once we find it, and we'll be done. So let's go do the Pythagorean theorem again. 3 squared plus, and I'll call it x squared equals 5 squared. You can do the math, or better yet, if you've learned some of those special triangles, 3, 4, 5. If you see this 3 and you know the hypotenuse is 5, I hope you can go, hey, I know that's a 3, 4, 5 triangle. So I'm going to save myself the math and find out the x is 4. And then I am done. Tangent of T is 4 over 3. As a decimal, that's 1.3 repeating. Okay, we're rolling. Example 4. Let's draw our own picture again. Solve the right triangle XYZ where Y is the right angle. So I'm going to put Y at my right angle and put in X and Z. And let's follow the rest of the information. Length XZ is 12 inches. Length XY is 8 inches. If you'd like to, you're probably guessing, we probably need to find YZ. So if you'd like to go ahead and start with the Pythagorean theorem, you can do that. 8 squared plus x squared equals 12 squared. 64 plus x squared is 144. X squared is 80. Square root that, and you should have x is 8.9. Of course, this is approximately, because we're having to rounding to the tenths. Now, we've got all 3 side values. The question is to solve the right triangle, so we need all 3 angle values. Other than the 90, we have nothing right now. So that just means we can use any trig function at all, because we have all 3 sides. Pick an angle, pick a trig function, and do the inverse trig function in your calculator, and you'll be able to find that angle measure. So I'm just going to choose angle X, and I'm going to choose cosine. I could do anything since I have all 3 side values. Cosine of x is adjacent over hypotenuse. So for this picture, that's 8 over 12. So if I would use my calculator and do the inverse cosine of 8 over 12, then that will spit out angle x. Go straight to your calculator, punch in inverse cosine of 8 divided by 12 and close your parentheses, and you'll come out with the measure of angle X to be, and I'm rounding to the tenths, 48.2 degrees. If I put in my 48.2 degrees, there's no real work left to find angle Z. Sure, you could do another trig function if you like, or you can simply go 90 minus 48.2, and the measure of angle Z would be left to be 41.8 degrees. You just solved the entire triangle. Okay, even though that took several minutes, I hope you saw just how easy it was. You've got to have some confidence in spotting your trig functions, and you can really use almost any of them to be able to solve a whole triangle. See you guys soon.